From Agerpoint, I'm James Kotecki, and this is The Point Cloud. My guest is the director of NASA Harvest, the National Aeronautics and Space Administration's global program to promote food security and agriculture with satellite observations. Dr. Inbal Becker-Reshef, welcome to the show.
Thank you.
How'd I do with that introduction? Is that how you introduce NASA Harvest when you meet someone at a cocktail party and tell them your cool title?
No, I think you did a much more dramatic and better job than I would. Next time I'll take you around with me to the cocktail party.
Well, NASA's all about dramatic, sweeping vistas of space and the planet, and that's what we're here to talk about. But before we get into all of that, I just want to know what drew you to this work? Where does the spark for the passion for satellite observation, NASA Harvest, where does that come from for you?
It's probably a combination of my experiences and on a personal level and then kind of as I developed professionally. I think I always knew that I wanted to make some kind of a positive impact. I grew up moving around every year or two. I lived on 3 different continents, saw a lot of different ways of living and also a lot of different challenges. And I started studying soil science and agriculture, and then kind of by chance got into remote sensing and started to recognize how important and how impactful that kind of technology can be. And I think it was a natural evolution, working with satellite data in agriculture and recognizing the impact that we can have and so much still untapped potential that we have using satellite data to make a difference. I know it sounds kind of cheesy.
No, but it's so cool what you're doing. So NASA Harvest, tell me the origin story then of NASA Harvest. Are you the first director of this? Is this a program that you helped to start? Where did this actually come from?
That's a really good question. So we launched NASA Harvest officially in 2017, but the roots for that program go a lot further back. I joined a team at University of Maryland that was working with USDA and NASA back in mid-2000s, who was already working on how do we better integrate satellite data into the USDA for an agricultural monitoring system. How do we make satellite data more accessible and kind of not needing to be a remote sensing specialist to be able to use that kind of data. And in doing that, we recognized that there were a lot of different countries around the world trying to do very similar things. And this was led by somebody called Professor Chris Justice, who I worked with very closely, and eventually brought together the international community under what's now called GeoGLAM. It's a G20 initiative. At the same time, NASA recognized that within its applied sciences program, and that's where NASA Harvest sits, didn't have a specific application area focused on agriculture. And so over the years, they made the case to put together a program that would be specifically focused on agriculture. And they wanted to look at a different framework or a different model for doing that than they traditionally had. And so initially, NASA Harvest was an experiment. They competed out the program. And the objective to setting it up in this way was so that it could have perhaps a bigger impact. So we could partner with governments more easily. We could partner with private sector companies, humanitarian organizations, because I actually don't sit inside of NASA headquarters. So I report into NASA headquarters. NASA Harvest is a headquarters program, but it's actually run out of University of Maryland. And that enabled us to be quite dynamic in terms of how we partner and run the program.
When I think about agriculture and space, if you say those 2 words to someone, they might be thinking about growing a new strand of wheat in zero gravity or terraforming Mars or something. Is that the reaction that you sometimes get when you start talking about this? Do people need to kind of reorient on the fact that, no, actually what we're doing is we're using satellites to look at agriculture on Earth, the most important planet that we know?
Yeah, that's right. Yes, but I would say less and less, right? So more and more people are aware that we're using satellite data in a lot of different ways for monitoring agriculture on our planet, on Earth. I do, of course, often get a question about, can we grow food on the moon and or other planets? But yeah, I think there is some element of surprise for people initially when they hear NASA and agriculture. But I think as this area and field really are growing very rapidly, there's more and more familiarity with this, and it makes more sense to people.
So how does this actually work in practice. Can you give us just like some basic numbers here, just a basic framework for understanding this? I know that there are a lot of satellites orbiting the planet right now. How many of them can we use for agriculture? How many does NASA Harvest actually use to look at agriculture? Do you share these satellites with other people? Or are you just kind of tapping into satellites that are there doing other things a lot of the time? Like logistically, what is actually happening with NASA Harvest?
So we use a lot of different kinds of satellites, both in the public sector and in the private sector. I think today there are around 1,000, maybe a little bit over 1,000 Earth observing satellites that are orbiting the Earth all the time, taking a lot of imagery. We've seen a really rapid increase in satellites in the last few years. I think if you look just like 5 or 6 years back, there would have been around 400 satellites that are Earth observing specifically. And one of the trends and why we see so many more of those is that there's been much increase in kind of sending up these fleets of satellites. Like you might have heard of a company called Planet, for example, or others that are working together in synchronous to ultimately enable us to have more frequent observations of the same spot all the time. Our primary data that we use have been the public, open, and free and open satellite data. So a lot of people might not recognize that a lot of the satellite data that's out there by NASA, by the European Space Agency and other space agencies are actually free and open, recognizing that to have an impact, the fact that satellite data are free and open means that we can use them and utilize the insights from them a lot more than if we have to pay for those. But there has become a really important role also for the commercial satellites, especially these kind of CubeSat small satellites that are lower cost than they would have been just even a few years ago, and also providing a lot of really valuable information. So on the NASA Harvest side, we are using a lot of different kinds of satellites that are, if you think about, they're monitoring the environment around us all the time. They're able to monitor almost every field across the globe on an almost daily basis. And so what satellites can do is they can see kind of in the same wavelengths that you and I see in the visible range of the electromagnetic spectrum, but they can also see in a lot of other wavelengths. And that means that we can see a lot of things that we can't see with the naked eye. And of course, we have the vantage point of space. And so we can see also a lot more at one time or monitor essentially the entire Earth every day.
So is it fair to say that you at NASA Harvest can basically see everything that humans are growing outdoors to eat every day? Close
to that.
Okay.
So we can see a lot of those fields. I think a lot of what it is being able to convert, this tremendous amount of data into actual information, right? Into what is each field growing? How is it developing? When was it planted? When was it harvested? What kinds of management practices were applied, right? Like satellite data can give us a lot of insights about that. But in order to be able to do that, that means we've got to develop models. We've got to have reference data from the ground that are training and developing these models to turn that data into actual information.
Can you speak a bit more about the way that this kind of fits into the overall puzzle here? Because someone listening to this for the first time might think, oh, we have total satellite coverage of the Earth. So as long as there's a plant growing outdoors, game over. We can see everything, and all we have to do is run some models on it. But you're talking about ground validation and other kinds of technologies. So how do satellites fit in your mind in the overall picture of how we collectively, whether that's you at NASA Harvest or just we as a species, kind of figure out and understand what we're growing?
Sure. So satellite data, one of the ways that we can, for example, identify a specific crop type and start to map it is it has different kinds of signatures, right? So if you want to, it has different signatures and different wavelengths in the visible versus the near infrared versus the shortwave infrared, but it also has a temporal signature that is very, very important, right? So it's planted, it starts to emerge, it grows, it will mature, it will senesce, it will be harvested. And so also looking at that signature through time and through different wavelengths becomes very important for then developing models that we can apply to then classify, for example, entire country or the globe. But what we need to do to be able to do that is that I need to be able to say, okay, this is what corn looks like, or this is what corn looks like in all possible different variations of it, train a model to then be able to pick that up, to understand that variability, and to then be able to map it. And then crucially, we need to be able to validate that map, right? So it's not good enough that I can run a model and produce a map that, a model will produce a result, but how good is that result? How accurate is that result? And that's something that we spend a lot of time, not just we, the whole remote sensing community spends a lot of time on being able to make sure that we understand the uncertainty about what we're producing, the types of information that we're producing. So having that connection back reference to the ground, to what we're actually monitoring, is absolutely critical for being able to use satellite data.
Makes sense. Are there other limitations when it comes to satellite observation in terms of agriculture data that people might not be aware of?
Sure, there are lots of challenges and limitations, right? Going from having the necessary ground data to looking at very complex agricultural systems. You can imagine smallholder systems that are very small fields that might have intercropping in the field. How do we monitor that? To being able to develop models that can forecast and predict yields accurately, to being able to monitor different agricultural practices. But when you start to be able to develop those kinds of products and start to understand what the uncertainty in those are, you can also start to answer really critical kinds of questions around, what's driving yield, where are yield gaps, what kinds of practices might be driving those, and those sorts of things. But there's also a challenge on the amounts of data that we have. How do we process it? How do we make that more equitable? How do we make sure that we are developing products that are actually going to be used, right? So how do we make sure that the things that we do are user driven, and that are ultimately going to be taken up? And that's a big focus for us on the NASA Harvest side. We try to always start with an end user, because otherwise, and that's really key for being able to bridge this kind of science and research into actually having impact in operations. Because if I'm going to develop a map and not having ever talked to you and you're in a Ministry of Agriculture, why would you ever use this map, right? So it's got to be co-developed. It's got to be, and I think the other side of that is really thinking about how do we ultimately boost that capacity to, in the institutions, to be able to uptake and use these kinds of information and satellite systems. So there are a lot of technical and a lot of other kinds of challenges, I think, in ultimately being able to reach the potential that satellite data offer.
So let's talk a bit more about how that plays out. So there's all this data. NASA Harvest is hopefully putting some analysis and insight on top of that data. So tell me about who you're sharing that data with and what they are actually using it to do. Let's get into some of the users and the use cases here.
And I should just say, we are one player in this field. So there's a lot of different entities and organizations that are developing different satellite products and information. And maybe one thing I didn't say up front was that NASA Harvest is a consortium. So we're over 50 different partners from across the world, from public and private sector organizations working together. But the types of users that we have range from humanitarian organizations, from UN types of organizations, to ministries of agriculture or statistical agencies, down to different kinds of private sector organizations, whether it's, we have some partnerships with insurance companies, some with farmer advisory, some with those that are really looking at the transition to sustainable agriculture and how do you better monitor or be able to show the different practices, for example, that farmers are implementing at a broad and large scale, or how do you understand what the implications of those can be? So we purposely have tried to target really across the agricultural sector, different types of end users for ultimately being able to uptake and utilize better satellite information.
Something that I know you've spoken about before, and that's certainly top of mind right now, is the work that NASA Harvest has done with its observations of Ukraine and agriculture production there during and subsequent to the Russian invasion. So I'd love to hear that story again for our audience. I think it's really fascinating and meaningful what you were able to do there.
I should probably say that I actually started a lot of my career in going into all this is working in Ukraine, and I did my PhD on yield forecasting of wheat in Ukraine. So spent a lot of time going to Ukraine and working with USDA and with partners in Ukraine. And so developed a lot of relationships doing that.
Just to say, I think Ukraine is a breadbasket, right? It's a major producer of wheat. And so the ability for them to be agriculturally productive is very important, not just for Ukraine itself, but for the broader region. Is that fair to say? Absolutely.
Absolutely. Ukraine is an absolute critical breadbasket. It produces, I think, prior to the war, was exporting around 10% of global wheat exports, about over 40% of sunflower oil, a very important producer for corn as well. And a lot of, I think, the World Food Program, in terms of its wheat food aid was over 40% was sourced out of Ukraine. And you have different countries that 80 to 90% of their imports of wheat, for example, depended on Ukraine. So a very important country. And when Russia invaded Ukraine, we immediately were in contact with the Ministry of Agriculture through connections and work relationships that we were already had. And they asked us to initially support their analysis and assessment of what was happening under the occupied Russian territories, temporarily occupied territories, where they didn't really have a lot of information coming in anymore, and where satellite data actually was providing the only means for really being able to monitor that entire territory. And so one of the first questions they asked us was, well, what proportion of Ukraine's croplands were under Russian occupation, and specifically what proportion of winter wheat, which is one of the main production crops in Ukraine, was under Russian occupation. We set up several different partnerships in order to be able to rapidly answer those questions. One of them was with the Institute for the Study of War that, as you probably know, provide every day an update on where that front line is and how that's moving. And one of the reasons this question was important too is that most of the statistics, even going backwards in time, are reporting on administrative level units, right? So but the line of contact or the occupation area, of course, doesn't follow any kind of administrative boundary. And so there were no statistics to be able to look at really what proportion is that occupying.
So the equivalent of a county or a state level production data, right? So
that's right.
Exactly. But of course, if half of that, I'm just going to say county or state or province is occupied and half isn't, then you don't have good data about how that could actually work.
That's right. Right. And so again, that's where satellite data can do that, because we can monitor it at the pixel level and start to then come up with statistics on that. And so we partnered also with Planet, one of those commercial companies that I talked about earlier, that has a fleet of satellites that gives daily observations. And that was very helpful for us because Ukraine can be very cloudy. And so it meant if a certain area didn't have a cloud over it, then we can start to, in a sense of thinking about it as a puzzle, every time there was a small area that didn't have clouds, you could puzzle that area together and mosaic that every 2 weeks to get a pretty close to cloud-free image. I should say that also radar data can help and do the same, and we also use those kinds of data sets. But so that was the first thing we did. And we found that around 22 to 23% of Ukraine's overall cropland, was occupied by Russia. And we found that around 29% of its wheat planted area was occupied by Russia. And then there were two really big uncertainties, and there were a lot of assumptions being talked about, which was how much of their spring planted area, right? So that's the corn, the sunflower, really important crops, would actually be able to be planted. Recognizing again that the winter wheat was planted prior to the war, so that area was going to be planted. But again, a big uncertainty, how much of that would actually be able to be harvested? And a lot of the numbers that were running out there was anywhere between 30 to 50% wouldn't be planted, wouldn't be harvested on the wheat side. And so we started to map. So the first thing we did was, of course, we mapped where the winter crops were. And then we started to follow all that area that could potentially be planted into spring crops. And what we found is that most everything looked like it was getting planted, including in the occupied territories. What we saw was that there was a concentration of fields that were not getting planted right along that line of contact, the occupation front line. But for the rest, a lot of the fields, or the majority of the fields, were being planted, and ultimately it was around 88% of field or of area in the occupied territories was planted. Sorry, so 88% was planted, approximately 12% was left unplanted in the occupied territories. And so that was very different than all the other numbers that were being put out there. The expectation was that a lot less would be planted. And then as the season progressed, we could progressively map other crop types and look at what was going on. We found that around 21% of the summer crops were under occupation, 14% of the winter rapeseed, this is an important oil seed, was under occupation. And we ultimately then, as the harvest season started to progress, we were monitoring then again the progression of the wheat harvest in particular. And again, what we saw was contrary to what most of the assumptions were, is that the fields were also all getting harvested. And this really surprised us. We did a lot of due diligence to make sure that we had a lot of validation. The way to validate what we were doing was to zoom in and look at the daily imagery at a 3-meter resolution and look at the actual day that we see the harvest happening. And so based on our maps, and I should say this before too, it's not enough to make a map out of remote sensing data. That map, we still need to run random stratified samples in order to be able to come up with actual statistics with an uncertainty around them. And so we did that for the harvested area. And again, what we found was the large majority of wheat had been harvested, including in the occupied territories. The area where we see most of the areas not being not harvested was again around that front line, the line of contact. And then what we could finally do is ultimately the number everybody's after is production. And so we took the yield numbers that were coming out of the Ministry of Agriculture for the Ukrainian controlled territories. We ran our own yield model on the occupied territories and where they didn't report. And so together with our area planted estimates, the harvested proportion of those, and our combined yield numbers from our side on the ministry, came up with around 26.6 million tons of wheat that were harvested. And that was much higher than expected, around close to 6 million tons above most leading estimates. And 22% of that production was coming out of the occupied territories. So what satellite data can do is it can show us that all that's getting harvested. What they can't do is tell us who's harvesting it, where is that wheat ending up, is it getting exported, where is it being stored, right? Like that, those are things we can't comment on or we can't see. What we can see and what we do is really very much try to stick to the facts and what we can monitor and observe, provide the validation, provide the uncertainty around those numbers. And so, of course, that brings a very important point. What happens to that 5.8 million tons of wheat that we saw that was getting harvested off of the occupied territories? And one of the things we saw is that a lot of the different statistics also that are coming out there is not always very clear. Is it talking about all of Ukraine? Is it talking about Ukraine minus Donbass and Crimea? Is it talking about, and so there's some variation in those statistics, but I do think it's important to really be transparent around what's being produced. It obviously translates into a tremendous loss to Ukraine, that 22% or those, 5.8 million tons. I think we estimated around $1.2, $1.3 billion in losses just from the harvested wheat to Ukraine. And we are working very closely with the Ministry of Agriculture. We are interacting with them very closely, providing these information and estimates. And I should also say we've collaborated and coordinated with other entities that are working on remote sensing, including a project called the ESA World Cereals. And so just to mention that there has been some exchanges and collaborations, but it did really enable us to be able to provide information in areas that otherwise there is no information or very limited information coming out. And I think that highlights really the value and importance of satellite data in these kinds of situations. Now, in Ukraine, this is due to war and conflict, but you can imagine an extreme event, right? A flood event or a drought or other. And as we see more climate change, we know there's an increasing frequency and severity of extreme events. And again, I think the value that satellite data can provide in terms of being very rapid, being able to look at a large swaths of land becomes very important and can provide really valuable information.
You mentioned that satellite data can take you much further than people might expect, but maybe not all the way towards kind of the actual truth of what's happening to that wheat. You can know how much is getting harvested. You can't exactly know who's harvesting it or what they are doing with it. Do you sense that policymakers, the people who use this data, understand that? Do you get people who come to you and want to use satellite data as kind of the be-all, end-all, and are maybe disappointed that it can't tell them these, quote, deeper truths that we want to get to? Or are people kind of understanding the role that satellites play and that they're a piece of a bigger puzzle?
I think for the most part, people understand that they are a piece of a broader, they have a role to play in providing information. I think on the remote sensing side, we always have to be very careful about not overpromising what the capabilities, what the accuracies are of the models or the maps and the statistics. And we've always got to be very careful to communicate uncertainties and what it can and cannot do. I mean, there were some interesting studies that we saw that were using satellite data actually to track ships and to track ships that go dark and then, come back. And that, that's certainly not our expertise, but there was actually utilization of satellite data for looking at that and still is as well by other groups.
Interesting. You mentioned getting down to a 3-meter resolution with the work you were doing observing Ukraine. Is that the state of the art right now? And is there an expectation about, in the near term, just how good this technology can get? Like, what's the cusp of what you're almost able to do? What are you excited about being able to do with the next generation of whatever the technology is?
Yeah, I think the resolution has to be suited to the task and to the target. So fields in Ukraine are actually really large. We didn't need 3-meter resolution to do everything we did. It was helpful. For example, we delineated the field boundaries, right, of every field across Ukraine. And for that resolution was actually very helpful. I think what's exciting about what's coming are also new sensors, there's hyperspectral, there's looking at more sensors that can provide more information, for example, on soil moisture, deeper into the soils, and more radar kinds of systems. But I think it's the combination of technologies that's very exciting, and being driven then and making sure that we're also investing in the systems, in the institutions that can ultimately use these and take those up. And so it's a combination of the cloud computing capabilities, the supercomputing capabilities, the machine learning and AI methodologies and models, but also driven by and working closely with domain experts in different areas in agriculture and policymakers, and making sure that we're able to convert really these large amounts of information into actually actionable data or actionable information. Yeah. And I should say one other thing that I'm particularly excited about, or that I think is really important, and one of the things, new initiatives that we're setting up under Harvest, is being able to set up a center for rapid response, agricultural rapid response, right? And so being able to rapidly look at these different kinds of situations. It might be uncertainty of a big producer exporting country, or it might be due to a flood or drought or other kind of a climatic hazard or disaster, or it might be due to conflict. But being able to very rapidly be able to respond into policy needs or into decision makers' needs, and being able to harness this technology through the large network of experts that we've developed, I think can be very important. And also thinking about anticipatory, right? Like, where might we see, and building out different scenarios as well. These kinds of data can be very important.
There's a famous picture of the Earth from space. I think it was one of the first pictures that was taken. And I think it's called the Blue Marble, where people looking at that picture had a new understanding and perspective on their home planet, maybe wanting to take a little bit better care of it. Does the work that you do have an emotional impact like that? Does it change your relationship to sound cheesy, how you see the world?
Yeah, absolutely. I mean, I think if you think about that blue marble, right, it was one, recognizing that most of our Earth is water, right? And like seeing this little dot of blue in the vast emptiness of nothing. This is our planet. This is the only place we have to live. And there's a lot of exciting space exploration, but this is our planet. And I think, food security is one of the biggest challenges we face today, climate change, right? There are a lot of, and those are obviously very closely intertwined. There are a lot of massive challenges that we see today. And I think this work, I would say for many people, is very personal. It feels like there is a lot we can do. We need to be able to measure, monitor, and be able to inform and understand, what are we doing? How do we make progress actually to our target goals, and looking at how do we ultimately live in a more sustainable way on this planet. We don't have more land we can cultivate. We have a lot more people coming. How do we do that? And I think decisions have to be driven by data and information.
Dr. Inbal Becker-Reshef, Director of NASA Harvest, thank you so much for joining us today on The Point Cloud.
Thank you. It's been a pleasure.
Well, that is our show. Thanks so much for watching. Please subscribe, rate us 5 stars, tell your friends, and join us on social media at Agerpoint, where the conversation continues. From Agerpoint, I am James Kotecki, and this is The Point Cloud.